everyone, welcome back to my channel, or welcome if you're new. Bella here, proud mommy of Peter, and this is my channel where I talk about technology, programming and gaming. So in today's video, I'm going to talk about how your web pages are rendered in your browser, how a HTML document turns out to become these beautiful pages we see in our browser. So let's start with the basic concepts of how a web page is built. When a browser receives a HTML document from the server, there are several steps included before the pixels can be drawn on your screen. This sequence of steps is called critical rendering path. Understanding this path can actually be pretty useful to create high performance and quick loading pages. The 6 stages of the critical rendering path, or CRP, are constructing the DOM tree, constructing the CSS DOM tree, running the JavaScript, constructing the render tree, creating the layout, and finally painting the pixels on your screen. So let's start with the first step, which is constructing the DOM tree. DOM stands for Document Object Model, and it's an object representation of the parsed HTML document. Starting from the root element, the HTML, which is the first one, the parent, nodes are created for each of the nested elements in it, and also the text and content are also included. Elements nested with other elements are called the children, the child elements, and the content we call the leaves. The nodes also are going to be including their attributes that were defined for each element. The HTML can be executed in parts. The full document doesn't have to be loaded for the content to start appearing in your page. You probably know that sometimes you see a piece of the web page here, a piece over there, but you don't see everything at the same time. Normally, sometimes you can use like loading screens before everything shows up or something like this, but if you're not, you can start seeing things popping up on your screen out of order. However, the CSS and the JavaScript can both stop and block the renderization. Once we have the DOM tree, we started creating the CSS DOM tree. CSS DOM stands for CSS Object Model, pretty similar to the DOM. This tree is an object representation of the styles associated to the DOM and to each of the elements. It's represented in a very similar way as the DOM, but it also includes all the inherited and declared CSS styles for each element. So I mentioned before the CSS is a render blocker.
You shall not pass!
Why is that so? Why CSS is considered to be a render blocking resource? This is actually due to the cascading nature of the CSS. I explained this cascading in the video CSS Basics that I'm going to leave up here. What that means is that sometimes you define styles for a specific element or a specific class. However, you also defined a style for an ID that overrides what you defined it for a certain class. This means that the whole CSS document have to be parsed in order to find out which styles have to be overwritten by heavier weighted styles like defined for an ID, as I mentioned before. Due to this cascading nature of the CSS, we need to wait for the whole document to be parsed and read because styles that are defined later in the document can override styles that were defined in the beginning of the document because they have a greater weight than the ones defined first. That's why we have to wait for the whole document to be parsed before moving on to the next step. Furthermore, the CSS can also be script blocking. That means that the JavaScript can only run once the CSS has been completely parsed. That is also because you can style an element as hidden or not display the element at all or change its position using CSS, and then if you target this element using JavaScript, it has to be there. So the JavaScript has to wait for the styles, it has to be certain that this element exists and it's being displayed in order to be able to work with it. So that's why the JavaScript can only run once the CSS has been completely parsed. So once the CSS home is built, we can finally run our JavaScript. So the JavaScript is considered to be a parser blocking resource. That's because the HTML parsing can be blocked by the JavaScript. Whenever the parser, when it's reading the HTML document, whenever it reaches a script tag, it stops and wait for it to be loaded. That means fetching the resource and waiting for it to be delivered by the server, whatever this thing that you're importing or calling is, and then it runs this script. That's why all the JavaScript files must be placed after the appearance of the document at the end of the document. However, we can overcome this issue by adding the attribute async into the script tag. This makes this file, this JavaScript, to be loaded asynchronously. Once our JavaScript has been completely fetched and run, we can start creating our render tree. So the render tree is a combination of the DOM and the CSS zone. It represents fully what's going to be displayed on the page. It only captures though the elements that should be there, that should be displayed. If an element is styled with the CSS property display none, for instance, it's going to be hidden and it won't be present in the render tree. It's going to be in the DOM, but not in the render tree. That means since it's still in the DOM, you can use JavaScript to have access to it and at some point make this element that was hidden show up. Finally, if we already have our render tree, we can start to generate our layout. The layout is what determines the size of the viewport. It can be mobile, it can be tablet, it can be desktop, portrait, landscape. Each of these devices is going to have the specific viewport size. With that, it provides context to the CSS styles that depend on it. For example, if you say in the CSS that you want something to have 40% of the width of the viewport, like this, it's going to be calculated according to the viewport defined in the document. The viewport size is determined by the method tag viewport and it's provided in the head of the document. Not your head, in the head of the document. If no tag is actually provided, there's a standard. It's 980 pixel, and if you don't provide this meta tag, that's what's going to be considered as 100%. Doesn't matter in what device the user is looking at your page, it's always going to be 100% considered as 980 pixels. The most common value for the viewport size is to simply define it as the width of the device, of the screen size of the user. And finally, once we have our render tree, our layout, we can start painting. Yeah, that's how it's called. It's called painting. That's the last step. And in this stage, the content of the page, the pixels are actually displayed on the screen. And this step actually depends, the time that this step takes depends on how complex the DOM is, as well of what styles have been applied in the document. For example, a very complex image gradient is going to take much longer to be painted on the screen than a simple solid color as a background. So that's it. That's how the critical rendering path works. I've covered all the steps and explained to you how each of them work and what's created after each of them. First the HTML, then the CSS, the JavaScript, then the render tree is created. So the layout is also then created from the render tree according to the viewport size, and finally the pixels are painted. That's it from me today. Like the video, subscribe to the channel. See you next time. Bye!